The record. Okay, this will be the last question that we do for today's meeting. So I don't know why, but I always like this one. There's some questions I just like the mosquito problem. I like. I probably I'm off topic, but because of my family's heart history, this appeals to me. My father survived a heart attack at age 40, and then at age 41 had another one, and that one was very traumatic for me, and he survived that as well. But as a result of that, heart problems are of interest to me. So this problem is of interest to me. So a French study was conducted in the 1990s to compare the effectiveness of using an instrument called a cardio pump with the effectiveness of using traditional cardiopulmonary resuscitation and saving lives of heart attack victims. Heart attack patients in participating cities were treated with either a cardio pump or CPR, depending on whether the individual's heart attack occurred on an even number or odd number day. Before the start of the day, a coin was tossed to determine which treatment, a cardio pump or CPR, was given. The other treatments was given on the odd number days. In total, 754 patients were treated with a cardio pump and 37 survived and at least 1 year, while 746 patients were treated with CPR and 15 survived at least 1 year. That's a very small survival rate, in my opinion. Notice the sample sizes were pretty close in size at 754 and 746, which is pretty good for randomization as opposed to an assignment situation. So the conditions for inference are satisfied in the study. State the conditions and how they are satisfied. And once again, and I should say this again, we had 754 and 37. And I look at that and I have two values. Neither are the mean and neither are the standard deviation. Probably going to be a test for proportions. And then I have a second set that's set up the same way. So basically this lets me know that I'm probably working with two proportions. So treatments are randomly assigned by flipping a coin to determine the type of treatment. Samples, and by the way, this changed because we're now working with an experiment. We assign treatments. So treatments were randomly assigned. And you could have said the two treatments were randomly assigned. And if you do say they're assigned, you need to say how they were assigned by flipping a coin. You don't have to say to determine, but by flipping a coin, they were assigned. Independence. You could have said two independent samples and they were randomly assigned, two independent random samples, and that would have been fine, but always say how they were assigned. So samples are randomly assigned, therefore they're independent. One doesn't impact the other, is in other words what you're saying. We need to make sure, another thing, when you're dealing with experiments, you do not need to check the N is less than 10%. When you're dealing with experiments, you do not need to check the N is less than 10%. I'm going to say that one more time. When you're dealing with experiments, you do not need to check that N is less than 10%. All right? So, but I do need to check that my samples are large enough. Well, it turns out I had 37 that survived, which I mean I had 754 minus 37, 717 who did not survive. Here, I had 15 who survived and 731 who did not survive. So both samples are large enough to use the normal approximation. At that point, I've satisfied the question, which was state the conditions and how they're satisfied. Satisfied by flipping a coin, random assignment by flipping a coin. I stated that they're independent, and then I stated that they were large enough by normal approximation, and to use the normal approximation, and I showed how they were. All right, part B. Perform a statistical test to determine whether the survival rate for patients treated with a cardio pump is significantly higher than the survival rates for patients treated with CPR. So I said P1 equals P2, and P1 is greater than P2. Well, if I define it that way, if I set it up that way, P1 has to be the cardio pump, and P2 has to be CPR. All right, so make sure your definitions, make sure your hypothesis match the statement. So P1, 37 out of 754, or 0.0, almost 5% survived with the cardio pump versus about 2% with the traditional CPR. Because we're working with two proportions and we're working with a hypothesis test, we need to combine them. I do want to offer a caution here that I haven't offered today. We only do this for hypothesis test. We do not do this for confidence intervals. Two sample proportion hypothesis test, we do this. Two sample confidence intervals, we don't do this. We also don't do this for t-tests. We only do this proportion, and we only do this for two sample proportions. Two sample proportion hypothesis test. So let's go ahead and run this test. Stat test, two proportion z-test. And our first sample had 37 out of 754. Our second sample had 15 out of 746. I have a greater than inequality, so I need to make sure I match that. I calculate, and I end up getting I copied this wrong. I hate when I do that. A z-score of 3.066. Make sure I did that right. I did. All right. So I ended up getting a very, very small p-value of 0.0011. One thing you noticed, I did not multiply by 2. I did not need to multiply by 2 because this is a one-sided test. You only need to multiply by 2 if it's a two-sided test. So I didn't need to multiply by 2. All right. This should be 3.066 is my z-score, and that probability is 0.0011, which is very small. With that small of a p-value, with any reasonable alpha, we're going to reject. So our p-value is 0.0011. We reject the null. There's sufficient evidence that alpha equal 0.05 to suggest that the true population proportion survival rate of patients using a cardio pump is greater than the survival rate of the patients who were given CPR. Simplified statement, we believe the cardio pump works better than CPR. Now my question is, can we make a causation statement? We know this was statistically significant, but can we make a causation statement? And the answer is yes. It was statistically significant, so we met the first criteria. The second criteria is it was an experiment, and because it's an experiment and not an observational study, we can say causation. So we can say that the cardio pump would save lives, all right? They didn't ask that part, but please always make sure if they do ask us whether or not we can say that we can make a claim that we can include or we can show causation, that we always sit there and go, was it an experiment? If it's an experiment, we can say there's causation. If it was just an observational study, we say that there was a relationship. We don't get to say whether there was an association. We do not get to say causation if it's an observational study. All right, so that should conclude today's. I'm going to stop the recording.